Hello, everybody, and welcome to lesson 4.1 about parabolas. So today is starting our conic section unit. So let's get cooking, looking at some conic sections. So what a conic section is a two-dimensional cross section of a cone. So these four illustrations here show the four different types of conic cross sections. So the four different types of conics. So the first one is a circle, which you dealt with in geometry. So we're not actually going to be doing circles in this class because you did a lot of analysis of circles in geometry. The second one is an ellipse. So you see we can create an elliptical conic section by doing a sort of diagonal cross section through a cone. You have probably in elementary school heard ellipses referred to as ovals. So the mathematical term for an oval is an ellipse. The next one is a parabola, which you've heard of parabolas before. What we're going to do in here, though, is we're going to give a little bit more rigid definition to a parabola and talk about some graphical features that you probably have not talked about before. And then the last one is a hyperbola. All right, so we're going to talk about about parabolas, ellipses, and hyperbolas in that order. So today we're talking about parabolas. So what a parabola is, again, you've seen graphs of parabolas before in algebra 1 and 2, but what a parabola is the infinite collection of points that are equidistant from the focus and directrix of the parabola. So what that means is inside of the parabola, there's some point that is the focus, and then outside of the parabola, there's this line, the directrix, that's perpendicular to the axis of symmetry. And what the parabola is I can take any point on the parabola, and the distance from that point to the focus will be equal to the perpendicular distance from the directrix to that point. So the shortest distance from that point to the directrix. So these two lengths will be equal no matter which point I pick on this parabola. So if I were to pick this point up here, these two distances will be equal. This distance here will be equal to this distance here. All right, I'm going to get rid of that because that kind of clutters up the picture. But so that is the rigid definition of a parabola. And so we say that these things are equidistant, which means that the vertex is going to be a very helpful point when we're looking at parabolas, because if we notice, the vertex is actually on the perpendicular distance from the focus to the directrix, which means this vertex right here, the distance from the vertex to the directrix should be the same as the vertex to the focus, which means what we're going to do is we're going to define this variable a as the distance from the vertex to the focus, which means that this is also the distance from the vertex to the directrix, which means the distance from the directrix to the focus is 2 times a. So it's 2 times that distance. So, and I'm going to show you why that's going to be helpful when we start looking at these equations. So these are the 4 ways that you might see equations of parabolas when we're talking about conic sections. So again, you can pause the video and write down any of this that you need to. But the basic idea here is if the vertex is at HK, and this is specifically for the axis of symmetry being parallel to a coordinate axis. So I do y minus k squared equals 4a times x minus h, and you notice all of those look somewhat similar. And over here, it tells me a rough idea of what the parabola looks like. So the way that I like to keep this straight in my head without having to memorize all of these equations is that either your x or your y term will be squared. So if you notice these first two, the y term is squared, the second two, the x term is squared. So if y is squared, that means the parabola is either opening right or left. And if x is squared, it's either opening up or down. So in both cases, we have a version where 4 is positive and then a version where the 4 is negative. So remember, we're defining a as the distance between the focus and the vertex, which means that a, since it's a distance, will always be positive. So the 4 is actually what's positive or negative here in this equation. So if y is squared and 4 is negative, it opens left. If x is squared and 4 is negative, it opens down. So that combination of thought process will help you get an idea of what this parabola looks like before you start answering questions. And then I have a note down here, if the vertex is at the origin, h equals 0 and k equals 0. So instead of looking like this would look something like, for the last equation, this would be x squared equals negative 4ay. Because if h and k are 0, then this is just x and this is just y. So again, I want to reiterate, the focus is a point inside of the parabola and the directrix is a line that's outside of the parabola perpendicular to the line of symmetry. So I don't know why I erased that. So we're going to take a look at a problem, or sorry, we're going to look at the visual examples. The reason I'm showing you these visual examples is it is going to be very helpful for you to draw yourself the information that you have available to help you visualize what's happening in this problem and help guide you when you're solving the problem. So each one of these is a visual example. This one opens right, which means I have a y that's squared and my 4 is positive. This one's opening left, so I have a y term that's squared and 4 is negative. Opening up means that my x term is squared and 4 is positive. Opening down means my x term is squared and 4 is negative. So let's take a look at some problems that we can solve with this information. So first we want to analyze this equation. So analyze this equation. What I have up here, these are the things that I want you to find. So I want you to find the focus or the vertex, the focus, the directrix, the axis of symmetry, and which direction it opens. So for this one, we're going to look at this. And again, it's going to be helpful for us to sketch ourselves a picture as poorly as you draw. Even if you draw as poorly as I do, still try and sketch yourself the equation. So first thing I notice here is that x is squared, which means this either opens up or down. I notice that this number here is negative, which means this is going to be opening down. And I also notice this is just x squared and this is just y. So the vertex must be at 0, 0. So if the vertex is at 0, 0 and it opens down, the parabola looks something like this. All right, so if the parabola looks something like this, the focus is going to be a point somewhere down this direction on the y-axis, and the directrix will be a perpendicular line somewhere up here. All right, so what I want to figure out is where exactly are that focus and directrix. So the focus and directrix can be figured out by finding out what A is. So remember, this equation would look like x squared equals negative 4ay. So if that's the case, then A must be equal to 3. Because 3 times negative 4 will give me negative 12. So if A is equal to negative 3, that means that the distance between the vertex and the focus is 3. So the focus must be down here 3 units down this way because the focus is inside of the parabola. So this is going to be at 0, negative 3. So the coordinates of the focus will be 0, negative 3. And then, sorry, we already determined this. This opens down. So the focus would be 0, negative 3. And then the directrix will be 3 units above that. So the directrix is going to be a horizontal line up here 3 units above that. So the directrix will be at y equals 3 because it's a horizontal line. So the directrix is y equals 3. So the axis of symmetry, remember from algebra 1 and 2, the axis of symmetry will go through the vertex of the parabola. And in this case, my parabola is opening down and it goes through the vertex. The axis of symmetry is vertical. So this is x equals the x coordinate of the vertex, which is 0, which makes sense because that's the y-axis and that's my axis of symmetry here. So this is one way that we could find some information about this graph from the equation of a parabola. So let's look at another example. This time I'm telling you what the focus is and where the directrix is located. So again, let's sketch ourselves a graph. So I've got a focus up here at 0, 4. And then I have a directrix at the line y equals negative 4. So if the focus is up here and the directrix is down here below the y-axis, that means this parabola is going to have to be opening up somewhere. And the other thing that I want to keep in mind is, remember, the focus or the line that goes from the focus through the vertex to the directrix is perpendicular to the directrix, which means the vertex has to be somewhere on this y-axis. And specifically, I noticed that the distance between these 2 points right here is 8, which means if the distance between these 2 points right here is 8, the vertex is halfway between the point and this line is 8, which means the vertex is going to be halfway between that. So the vertex again here will be at the origin at 0, 0. And if the focus is up here, this parabola will be opening up. So this parabola is going to open up. I noticed that the vertex is at 0, 0, so the axis of symmetry will be the vertical line that goes through this point. So that, again, will be x equals 0. So now I want to write the equation. So the general form of this equation, because it's opening up, this is going to be an x squared equals 4ay. And if a is the distance between the vertex and the focus, then that's going to be 4 units. So in this case, this equation will be x squared equals 16y because a is equal to 4. All right, so I hope you're doing okay so far. Again, if you need to rewatch anything or go back through the logic, rewind the video and watch it again because we're going to do a few more problems. I'm actually going to save this one for class. So we're going to do this one. This one has a vertex that is not at the origin. We're going to do this one in class. And we're going to take a look at this one because this one also does not have a vertex at the origin. And we're going to describe this graph. So for this graph, the first thing, so here's the logic that goes through your head. First, determine the direction of the opening. So the direction of the opening, I noticed this is a y squared part. So this is either opening right or left. This is positive, which means that this graph is opening right. So this is going to open to the right. Next, determine where the vertex is located. So this is x plus 4. So the x coordinate of the vertex must be -4. The y coordinate of the vertex must be 1. So it has a vertex here at -4, 1. All right, so I've determined the direction of the opening. I've determined the vertex, which means that this thing is going to open to the right. And then the axis of symmetry in this case will be a horizontal line that passes through the vertex. So then this is going to be y equals 1. So now I need to find the focus and the directrix. So based on what I see in this equation up here, this 12 is 4 times a. So 12 is equal to 4 times a, which means that a is equal to 3. So if a is equal to 3, what that means is the distance between the vertex and the focus is 3. And the focus will also lie on the axis of symmetry. I don't think, let me go back. I feel like I failed to mention that the first time. If you notice, the vertex and the focus are both on the axis of symmetry. This will always hold true in every parabola. I think that I failed to mention that when I was talking about the first time, but it will happen. The vertex and the focus will both lie on the axis of symmetry. So really what I'm looking for is I'm looking for a point that is 3 units to the right of this point. So 3 units to the right of this point would put me here at -1, 1. So the focus will be at -1, 1. The directrix, I would go 3 units to the left of this and then draw a line perpendicular to the axis of symmetry. So this directrix would be at x equals -7. And now I found everything that I needed for this graph. All right, I hope you're hanging in there so far. I know there's a lot of information thrown at you. Again, pause the video if you need to, and we're going to do plenty of practice with this in class. So now let's look at page 10 of this slideshow right here. So analyze this equation. So this one is a little bit different because it's not already in the form that I wanted it to be in. There's a couple things I noticed here. First of all, I noticed I have an x squared, which means if I want to write this in the form where I can just read off the vertex and the focus, what I can do is complete the square in order to write this as a perfect square. So what I'm going to do is I'm going to put the x terms on one side and then the y term on the other. So I've got x squared plus 8x, something is going to go here, equals 16y. So right here, I need to complete the square. So if you don't remember the process of completing the square, you're going to take this b term, divide it by 2, and then square it. So pretty straightforward. So 8 divided by 2 is 4. 4 squared is 16. So what I need to do is I need to add 16 over here. And when I add 16, that means that I can rewrite this as x plus 4 squared. If you don't believe me, distribute this and you get that. The reason this is 4 is that's what I got when I divided 8 by 2. There is a longer explanation to that you hopefully learned when you were learning how to complete the square. If not, I will have a video about completing the square for my Algebra 1 class shortly if it's not already up. Depends on when you're watching this video, and you can go back and watch that. So the other thing that I need to keep in mind, though, is I can't just add 16 to one side of the equation because that's an algebraic flaw. You can't just add 16 to one side of the equation. What I do to one side of the equation, I have to do to the other. So if I added 16 here, I'm going to add 16 here. My other option could have been I could have subtracted 16 over here as well, but that's not really going to help me here. I just need to make sure that I maintain equality in this algebraic statement. So in this case, I have added 16 here. I added 16 over here. And now I notice I can factor 16 out of both of these terms. So this would be 16 times y plus 1. And now this is in a form that looks the way that I wanted it to look. So the vertex I can read off of here now. The vertex would be -4, -1. This is an x squared and this number is positive. So that means this opens up. If this opens up, the axis of symmetry is an x equals, and specifically it's x equals the x coordinate of the vertex. So now I'm going to draw myself a picture now that I have some more of this information. So I'm at -4, -1. This is opening up with an axis of symmetry that goes through here. All right. Now I need to find A, and I notice right here 16 is equal to 4A. So then A must be equal to 4. So if this is opening up, the focus is going to be 4 units above this point, which would be right here at -4, 3. So this would be -4, 3. The directrix would be 4 units below this point, so down here. And a y coordinate 4 units below this would be -5. So this directrix is going to be at y equals -5. And now I have all of my information from this. So if my equation looks something like this, I'm going to have to complete the square, write my squared term as a perfect square, and then factor things out until I have it in the form that I want it to be in. So that is it for today's topic. So today we talked about equations of parabolas, analyzing graphs of parabolas by finding the focus, the directrix, the direction of the opening, the axis of symmetry, basically finding really rigid definitions of a parabola and describing it very acutely. And then number 3, rewriting equations to analyze graphs of parabolas. So that's when we just did the completing the square to analyze the graph of a parabola. So if you have any questions, I hope you bring them to class. In class, we'll talk about a few things that we can do now that we know all this information. And I hope you come to class ready to learn. And I hope you have a fantastic day. I'll see you in the next video.